Okay, so today we're going to talk about the vertex form of quadratics. The vertex form is y is equal to a times x minus h squared plus k. So a, h, and k are all integers. X is our normal x and y is our normal y. So the vertex to get from this form is whatever h comma k is. Now this is a point, some point on our parabola, so let's draw a parabola here. It is the point where you have a minimum or a maximum. So the vertex is either the very, very bottom or the very, very top. Now notice that whenever you pull your h and your k out of your formula, so let's just take a look here. This h in our formula is a negative sign, but we have a positive sign here. So we have to change the sign of h whenever we extract it from our form. And then k is just whatever this sign is. So also, from this we can tell what the axis of symmetry is. The axis of symmetry is a line, and it's always an x equals line, so it's a line that goes straight up and down, and it's always x equals whatever h is. So going back to our picture, it's some line going straight up and down that forms a line of symmetry with our parabola. And symmetry meaning we can fold it over on itself. Also, something else we can tell about it is if it opens up or if it opens down. So it opens up if a is positive, and it opens down if a is negative. Now, on this example that I have drawn over here, we have it opening up. So whatever our formula is for, or our vertex form is for that particular function, a is positive. Okay, moving on to our first example. It says name the vertex, axis of symmetry, and if it opens up or down. So we're just going to be using what we talked about on the previous slide. So we want to pull out the vertex, the axis of symmetry, what we're going to get from the vertex, and if it opens up or down. So that's where we look at our a value. So the vertex, for this one, we're looking at our h and our k. Now this is our h, and this is our k. So when we pull out the h, we need to change the sign of it. So instead of a negative 3, we're going to have a positive 3. And our k takes the sign that's in front of it. So we have 312. So from this, our axis of symmetry is just x is equal to, and whatever x is in that point. So we have x is equal to 3. Then the last thing we got to tell is if it opens up or opens down. So we're going to look at that a in front of it. We have a negative a, so that tells us that it opens down. Okay, now moving on to example number 2. So we're going to pull the vertex out. So we're looking at this number and this number. So our h, we're going to change the sign of it so we have a positive 1. So our vertex, we have a negative 1. And our k is just whatever that number is. So we have a negative 3. Now our axis of symmetry, we're going to get from our vertex, it's always x is equal to, and whatever x is in that point. So we have x is equal to negative 1. Then lastly, we need to take a look at our a and see if it's positive or negative. Now, there actually is not a number written there, but remember what's understood is that we have a 1 there. In this case, we're going to have a positive 1. So since a is positive, it's going to open up. All right, moving on to our last example. So our vertex here, we have our h, but there's not a k written there. That's okay. Our h Same thing, we pull out that 4, but we have to change the sign of it. So we have -4, but technically our k is 0. Even though we don't have to write +0, our k is 0. Now, our axis of symmetry, this is the easy one. It's x equals and whatever x is in our vertex. And then lastly, we got to decide if it's opening up or down. So a lot like B, we don't have a number written here. But what's understood there is a 1, but in this case, it's negative. So it's going to open down. Okay, so whenever we're given these quadratics, normally they're not written in vertex form. So we're going to use some manipulation to get it into vertex form. So something that we can use. So when we write the quadratics in vertex form, we need to use completing the square, which we talked about last week. So example 2 says we're going to write in vertex form. And let's look at A. So here we have a quadratic, but it's not in vertex form. So what we're going to do is we are going to use completing the square, and we are going to set it up just like this. We're going to say y is equal to, and we're going to have x squared plus 8x plus something minus our 5 from before. Now, the way we're going to make sure that we're being fair here is whenever we're adding something, we also got to subtract it. Okay? So, if you add 5, as long as you subtract 5, we're fair in math. So, let's do completing the square here. So remember, for completing the square, we take our b, which is 8, and we divide it by 2. So we have 8 divided by 2, which is 4. Then we've got a square of 4, and we get 16. So that's what goes in the blank here. We have 16 and 16. See, here we're adding 16, and here we're subtracting 16. So we're adding it and subtracting it, so therefore we're not changing the problem. So now, since you guys are excellent at completing the square now, we're going to factor this guy. I'm going to kind of cheat. So we have x, then we're going to use that number. Then we have plus 4 squared. So all we did was we factored this, and it turned out to be this, which we talked about last week. So then we've got to take care of what's out here. So if we add the -5 and the -16, we get minus 21. Now here is our vertex form. We can easily tell what the vertex is. So let's go through and let's name all these things we know about it. So our vertex is, we take this 4, we change the sign of it. So we have -4, and here's our k, which is -21. The axis of symmetry is x is equal to whatever the x is in that point, so -4. And then lastly, we're going to open up or down. So look in front of our parentheses, that's where our a is. We don't have an a, technically it's 1, but it's a positive 1, so it's going to open up. Let's look at B here. Now, the difference between A and B is that we have a number in front of our x squared term this time. Now, we can't use completing the square until we just have a plain x squared. So we're going to look at these two terms, and we're going to pull out a 4 because we have a 4 here. So we've got to factor out a 4. 4x squared divided by 4 is just x squared. 8x divided by 4 is 2x. Then we're going to add something. This is where we're going to use completing the square. And then we have minus 3. Now, here's where things get tricky. This is where people start making mistakes. Now, normally, since we're adding something here, we've got to subtract it out here. Now, we're still going to do that. But whatever we put in this blank, technically, we're multiplying it by 4. Because if you use the distributive property, we're adding 4 times whatever goes in that blank. So since we've got to add 4 times whatever goes in that blank, we've got to subtract 4 times whatever goes in that blank. So this number needs to go here as well. So now we can complete the square. So let's take our b. Our b is 2. And we're going to divide it by 2. And we get 1. Then we've got to square it. 1 squared is 1. So that's what goes in our blank. And it goes here also. Now, think about it. If we distribute here, we get 4. So we're adding 4. But also, when we do this, we're subtracting 4. So we're being completely fair here. Okay. So let's move on. So we have y is equal to, now this 4 is still on the outside. This guy right here factors to x plus 1 squared. Then we've got to take care of all of this. So we have negative 3 minus 4, so we have minus 7. So now we can tell all the important information. Our vertex is negative 1, negative 7. My axis of symmetry is x is equal to negative 1. And lastly, if we take a look in front, that 4 is positive, so it's going to open up. Okay, moving on to example C, 2C. Now, similarly to B, we've got a number in front of our x squared, but this time we got a negative number. Now, doesn't matter, we are still going to have to pull out whatever is in front of our x squared term out of both of these terms. So let's do that. So we have a negative 3. Now, if we divide negative 3x squared by negative 3, we get x squared. Now, 6x divided by negative 3 is a negative 2x. Now, you can just check that by redistributing here. We get positive 6x, so we're good. So we've got plus something. That's where we're completing our square. And we still have our minus 1 out here. Now, remember, since we're adding something, we've also got to subtract something. But, remember, we got to take this number, and we got to put it here. Okay, so let's fill in our blank. So we take our b, which is negative 2, divide by 2, and we get negative 1. Then we got to square negative 1, and we get positive 1. So positive 1 is what goes in these blanks. So now, when we factor, we get y is equal to negative 3. Factor in this guy. You end up with x minus 1 squared. Then, what we have here is negative 1 minus this, excuse me. From here we get a positive 3. So you have negative 1 plus 3. So we get plus 2. Sorry, I got a little tongue-tied. Now from here, we can tell our vital information. Our vertex is opposite side of this, so positive 1, 2. Our axis of symmetry is x is equal to 1. And taking a look at our a, since we have a negative, it's going to open down. Okay, here's our last example. It says, write an equation for the parabola given the vertex and a point that lies on the parabola. So let's bring back our vertex form. We have y is equal to a times x minus h squared plus k. So remember, h and k is our vertex. A is the number that tells us if it opens up or down. Now, what we have here is we're given our vertex. We're given an h and a k. And we're given a point. Now, don't forget a point is just an x and a y value. So what we're going to do is we're going to plug in the y from our point, the x from our point, the h from our vertex, and the k from our vertex. And we just have to solve out for a, and then we're going to have our vertex form of our equation. So using the form, we're going to plug in. So y in this case is 18, and that's equal to a, which we don't know. Oop. X is 3 from the point minus, and we got to use parentheses here. Our h this time is negative. So we have minus a negative 1. Then we're going to square it plus our k, and our k is 2. So remember, this is our x, our y, our h, and our k that we're plugging in. So now we only have one unknown. We just got to figure out what a is. So let's solve out for a. We have 18 is equal to, and let's take care of these parentheses. 3 minus negative 1 is 3 plus 1, so we have 4 squared plus 2. So we have 18 is equal to a, and 4 squared is 16 times 16 plus 2. A lot of people don't like to write it that way, so I'm just going to rewrite this as 16a plus 2. So we got to subtract 2 from both sides. We get 16 is equal to 16a. Then we divide by 16, and we get 1 is a. So the last thing we need to do is we need to write our equation. Now remember, we're going to leave our x and y out this time. So our final equation is y is equal to a, but a is 1, so we don't really have to write it, but we're going to write it just to be safe. So we have x minus our h, so x minus our negative 1 squared plus our k, and our k is 2. So let's make this a little bit more beautiful. We're going to drop the 1 here, so it's x plus 1 squared plus 2. And there's our final answer.